So I'm given a recursive equation and I'm given one of the terms, but I want to write what the explicit equation would be. So if I want to write the explicit equation for this sequence, then I'm going to go ahead and take the fact that I know that t of 4 equals 13, and I'm going to find the next couple terms to make sure that I know my common difference, and then work my way back to find t of 0. So I already know that my fourth term is 13. So if I know my fourth term is 13, then I know that t of 5 equals 13 plus 2, which is 15. And I know that t of 6, so the next term, equals the previous term, 15 plus 2, which is 17. And so if I look at my sequence, it looks like my common difference is plus 2, because every time I go down, every time I move to the next term number, I'm adding 2. So to go backwards, I want to subtract 2. So that way my common difference looks the same throughout. So 13 minus 2 is 11. So again, 11 plus 2 is 13. 9 plus 2 is 11. 7 plus 2 is 9. And 5 plus 2 gives me 7. So t of 0 equals 5. So I know that t of 0 equals 5. And then I know that my common difference is plus 2. And you guys saw it right here. My common difference was positive 2. So I used my common difference, or I used my recursive equation to fill out this table of terms to verify my common difference. I used my common difference and worked backwards. Now I have the information that I need to write my explicit equation, which is that t of n equals my common difference times n plus my starting value, which was 5. So my explicit equation was t of n equals the common difference times n plus 5, or 2n plus 5. So my common difference was already given to me in my recursive equation, but I had to work back to find 0. So now I'm given an equation, an explicit equation rather, for my sequence. I want to find the recursive equation. And so I want to find the recursive equation for my sequence. So I got to look. I already know in my head that, again, my sequence has my common difference and t of 0. And the way I check that, again, is that t of 0 equals 4 times 0 minus 2. So if I simplify, 4 times 0 is 0. I subtract 2, it's negative 2. And if I want to find t of 1, then I do 4 times 1 minus 2. 4 times 1 is 4. 4 minus 2 is positive 2. T of 2 equals 4 times 2 minus 2. 4 times 2 is 8. 8 minus 2 gives me 6. And so if I look, as I increase from term to term, I'm adding 4 to get there. So my common difference is 4. And so I know that if I wanted to find t of 3, if I already know t of 2, so to find my next term, I know that t of 2 plus 1, so the term that comes after 2, t of 3, is going to equal t of 2, which was 6, plus 4. And so if I wanted this equation to be for the nth term, I know that t of n plus 1, so my next term equals the previous term plus 4. So writing the recursive equation for my sequence, I know that the next term is going to equal 6 plus 4. The next term equals the previous term plus 4. And now I have my recursive equation for the explicit equation I was given.